All right, so this video, let's take a look at differentials. So here we've got a graphical representation. So I have a curve here, y equals f of x, and here's the tangent line to that curve at this particular point here. All right, so if we go over on the x-axis, delta x, or delta x is equal to dx here. So if we go over that many units, delta x units to the right, well, this dimension from this point here to this point here on the tangent line, that's dy. Okay, so dy represents how the tangent line rises or falls, okay, or the change in linearization. And then delta y is from this point to this point right here. That tells you how much the curve rises or falls. So how do we calculate delta y and dy? Well, dy, that's just the derivative of the function times dx. So dy is f prime of x dx. So it's not really a lot different than what you've been doing, taking derivatives. You're just taking the derivative of the function and then times dx. And then delta y, that's f of x plus delta x minus f of x. That's the change in the y values on the curve. That's all that is. So let's look at a couple examples. All right, so in this example, they want us to compare the values of delta y and dy if our function is x cubed plus x squared minus 2x plus 1, and x changes from 2 to 2.01. All right, so what we've got to do here is we've got to find out what delta x is. Well, delta x, that's the change in the x values. So that's 0.01 in this case. I just did this value minus this value. A lot of times in the problems that you get, they'll put, they will give you delta x. They'll just come out and say, okay, delta x is 0.01. And then, of course, they'll have to give you the x value. But in this case, they give you the x value of 2, but then you have to calculate delta x because they give you the 2.01. So you do the 2.01 minus 2, and that gives you 0.01. All right, so let's go ahead and calculate delta y first. So remember, delta y is f of x plus delta x minus f of x. And so this is going to be f of 2.01. All right. So, I mean, in this problem, they gave you the x plus delta x, which is 2.01. If let's just say they didn't give you this value here, and they tell you x is 2, and they give you delta x is 0.01, then you would do 2 plus 0.01 here, and that would give you the 2.01. Okay. All right, and then that's going to be minus f of 2. See, f of x, in this case, x is this 2 here. And so this is going to be 2.01 cubed plus 2.01 squared minus 2 times 2.01 plus 1 minus, and that's going to be 2 cubed plus 2 squared minus 2 times 2 plus 1. And punching that into your calculator, you will get 0.14 0.0701. All right. Now let's find dy. So dy, I'm going to take the derivative of this function. So that's 3x squared plus 2x minus 2, and that's times dx. So now I need to evaluate this. Well, remember, x is 2, and dx, which is equal to delta x, is 0.01. So that's going to be 3 times 2 squared plus 2 times 2 minus 2, and this is times 0.01. And you punch that into your calculator and you end up with 0.14. And what it's showing you here is these two values aren't that far off. See, this is what we're looking at. We're looking at that's this difference from here to here. And you can see they weren't off by much. So we can get a pretty accurate calculation from dy. All right, so let's look at our next example. It says the radius of a circular disc is given as 24 centimeters with a maximum error in measurement of 0.2 centimeters. Use differentials to estimate the maximum error in the calculated area of the disc, and then find the relative and percentage error. All right, so for part A, all right, so the radius of a circular disc is given as 24 centimeters with a maximum error in measurement of 0.2 centimeters. So use differentials to estimate the maximum error in the calculated area of the disc. All right, so we know the area is pi r squared. Now that's the area of a circle. And so if I calculate the differential, that's 2 pi r times dr. And so this is going to be 2 pi times, and then r in this case, well, it tells us the radius is 24, and the error in measurement is 0.2, that's dr. And so we get, when we punch that into our calculator, that is 2 times 9.6 pi. So that answers part A. Now for part B, okay, they want to know the relative error. I'll use a different color here. All right, so for part B, I'll just abbreviate relative error as RE. Okay, so the relative error is delta A over A, which we can approximate this as dA over A. All right. So this is going to be what? Well, dA is what? That's this. That's 2 pi r dr over the area, which is pi r squared. And so let's see, that's going to be 2 times dr over r. See, the r's cancel. I'm left with the r here, and the pi's cancel. And so this is going to be 2. It's going to be 2 times. So dr is what? 0.2 over r, which is 24. And so that is going to give us, let's see, 2 times 0.2 divided by 24 is 0.016. Well, 0.167. So this is your relative error. And then the percentage error, well, that's just the relative error times 100. So that's going to be 1.67%. All right, so I hope this video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.